Welcome to the class of mathematics. I hope you have enjoyed the previous lecture. In today's lecture we will discuss that algebra of matrices. So what we are waiting for, let's start. Let us first define the quality of matrices. Two matrices A is equal to A by J, and B is equal to B by J are equal, written as A is equal to B if and only if 1. Both A and B are of the same order. Second, the corresponding entries of A and B are equal. That is, A by J is equal to B by J for all I and J. For instance, A and B are equal matrices, as they have the same order, and their corresponding entries are equal. Thus, we conclude two matrices A and B are called unequal if either of condition first or second of the above definition does not hold. Let us solve an example. As the orders of the two matrices are same, they are equal if and only if the corresponding entries are equal. Thus, by comparing the corresponding elements, we get 3x plus 4y is equal to 2, x minus 2y is equal to 4, a plus b is equal to 5, and 2a minus b is equal to minus 5. Solving these equations, we get x is equal to 2, y is equal to minus 1, a is equal to 0, and b is equal to 5. Algebra of matrices. Basic operations on matrices are: first, addition, subtraction of two matrices; second, multiplication of a matrix by a scalar; and third, multiplication of two matrices. But keep in mind that there is no concept of dividing a matrix by another matrix. Let us discuss the above one by one. Addition of matrices. If A and B are two matrices of the same order, then their sum, denoted by A plus B, is again a matrix of same order, obtained by adding the corresponding entries of A and B. Let us consider an example. We have two matrices A and B. Both have the same order, thus they are conformable for addition. Now to find A plus B, we need to add the corresponding entries. That is, first row and first column element of A is added to first row and first column element of B. Similar remarks holds for the other positions. Thus we obtained A plus B, which has the same order as A and B. Subtraction of matrices. If A and B are two matrices of the same order, then their difference, denoted by A minus B, is again a matrix of same order, obtained by adding the additive inverses of the elements of B to the corresponding elements of A. Multiplication of a matrix by a scalar. For a given matrix A by J of order m by n and a scalar k, we define a new matrix K times A B by J of order m by n, where B by J is equal to K times A by J for all I and J. Multiplication of matrices. A matrix A is said to be conformable for multiplication with a matrix B if the number of columns of A is equal to the number of rows of B. That is, if A and B are given two matrices of order m by n and n by p respectively, then the product of the matrices A and B is denoted by AB and its order is m by p. Keep in mind that the order of AB is m by p is equal to number of rows of A by number of columns of B. If I is a matrix of order m by n and B is a matrix of order n by p, then the product AB is a matrix C of order m by p, with Ci, J is defined as the sum of the product of the corresponding elements of the ith row of I and jth column of B, where Ci, J is an element. Matrices multiplication can best be remembered as row-column multiplication. Let us take some examples. Here the two matrices A and B are conformable for multiplication AB, because the number of columns of A is equal to the number of rows of B. So by definition we have to multiply first row of A to first, second and third columns of B respectively. Similar procedures can be adopted for the rest of the rows A and columns of B. Thus we have a matrix C, whose rows are equal to the rows of the matrix A, and columns of the matrix B. That is, C is a 3 by 3 matrix. In this example we want to show you that the product of two matrices is not commutable in general. Here matrix A and B are conformable for multiplication, as the number of columns of A is equal to the number of rows of B. So the result AB will be of order 2 by 2 matrix. Let's follow the remark row-column multiplication. The matrices A and B are also conformable for multiplication BA. since the number of columns of the matrix B is equal to the number of rows of the matrix A. Thus resultant matrix B will of order 3 by 3. From 1 and 2 we see that AB and BA are defined, but their result is not the same. That is, AB is equal to BA is not necessarily true. Hope you will understand the algebra of matrices. Now it's time to subscribe, like, and share my channel, Maths for You by Attaur Rahman. And do not forget to press the bell icon for more such types of videos. See you in the next video. Bye.